Welcome to the ATCO Sustainable Solutions webinar series. Thank you for joining us today to learn more about the project lifecycle of remote community clean energy projects. My name is Filip Palasz. I'm the Business Development Lead for our Off-Diesel initiative with ATCO, and today I'll serve as your webinar moderator. This is the third webinar in our four-part series, and in case you missed the first two, you can visit our website to watch them anytime. The webinar will also be posted on the website following today's presentation, and we'll just pop the link into the chat for your bookmarked page. Before we begin, however, I'd like to start with a land acknowledgement. I'm joining you today from Whitehorse, Yukon, which is the traditional territory of the Kwanlin First Nation and the Ta'an Quechan Council. However, as many of you are joining from other places across the country, I encourage you to take a moment to acknowledge the land you're on and the Indigenous people who've been stewards of that land since time immemorial. We strongly encourage you to ask questions and at any point throughout the webinar using the Q&A panel in Teams. Whether you're on desktop or mobile, you'll find the Q&A drop-down icon in the upper right corner and the full Q&A panel on the right-hand side of your screen. You may not see your question published until closer to the end of today's presentation, so no need to submit your question more than once. If we don't get to all your questions, we will connect with you directly after the webinar. Just make sure you include your name and please do not submit anonymously. At the end of the presentation, we'll include our contact information to connect with us anytime. For those of you unfamiliar with ATCO, we are a one-stop provider of integrated energy, housing, transportation, and infrastructure solutions. For 75 years, we have worked in more than 100 countries around the world to provide customers with innovative, sustainable solutions in the sectors that are fundamental to global growth and prosperity, such as housing, real estate, energy, water, transportation, and agriculture. From the delivery of efficient and reliable energy for homes, businesses, and communities to affordable temporary and permanent housing, we build communities, energy industries, and deliver customer-focused solutions across the globe. Building respectful and mutually beneficial relationships with communities, industry, and government has long defined how we do business, and we are always looking for opportunities to better collaborate with communities to better help them meet their goals. We also have a strong commitment to material economic reconciliation opportunities with Indigenous people. The sharing of economic benefits on energy projects is a tangible and necessary step towards authentic reconciliation, and ATCO has been an active partner in that space. Joining us today for our webinar are two of ATCO's finest subject matter experts for the execution, procurement, and construction of clean energy projects. Firstly, we have Anton Vinish, who is an execution and delivery manager with ATCO InfrastructureServices. Anton is a master electrician with 17 years experience in the electrical industry, comprising industrial, substation, commercial, and renewables construction. Additionally, he has held several supervisory and leadership positions throughout his career and is currently leading a 5-megawatt solar project for ATCO InfrastructureServices. Presenting along Anton is Ziad Mehman. Ziad has over 7 years of experience in engineering design, construction, coordination, and project management for industrial, commercial, and residential projects. He is an alumnus of InnoEnergy, the innovation engine for sustainable energy across Europe, which is supported by the European Institute of Innovation and Technology. Under the dual degree program, Ziad's graduate studies focus on smart electrical grids and electricity markets, including project and coursework at top European institutions and organizations, which exposed him to the technical, economic, and social effects of electrical sector decarbonization. Welcome, Anton and Ziad, and over to you.
Thanks, Philip. It's my pleasure here to be here presenting today. So I guess to kick things off, in this four-part series, and we're touching on groundbreaking today, we're going to focus on engineering, procurement, and construction, and those phases of your project. So at the end of this session, we hope that you'll have a better understanding of kind of these following bullets that are up on the slide here. So the engineering, procurement, and construction phases of your project. We're going to discuss how an EPC can help you be successful with your project. So recognizing that each community is unique and different and will have different challenges that they need to face. So there's no real one size fits all, but we just recognize that each community is definitely unique. We'll explore misconceptions surrounding how a project needs to progress. The right progress and the right approach may depend on the customer stage of development at the time. We'll talk about how to differentiate long lead items from materials that are readily available, so you don't start construction while waiting on critical items to arrive, preventing construction delays. And lastly, as well, we'll be highlighting the importance of how your project can also support local business and community growth while ensuring your project is completed safely, on schedule, on budget, with a high degree of quality. So at the beginning, really high level here, this is the typical flow of an EPC renewables project. So beginning with, you have your pre-EPC activities, and I think if you caught the first webinar sessions, those were discussed, and we're going to touch a bit on those again as a bit of a recap here. But and then you have your engineering time, and you're progressing through to procurement afterwards, your construction process, commissioning, and lastly your operations and maintenance. So we'll discover though that there is an opportunity to break from this typical flow process and maximize your project schedule to create efficiency within that EPC process. So let's take a look at the closer look at this EPC process, and I'll pass it over to Ziad.
Thanks, Anton. Before the project moves towards the execution phases and before engaging the EPC, there are initial steps that need to be undertaken. This is where the owner would begin with the pre-feasibility, feasibility, and the FEED design stages. For simplicity, we will lump the first three items on this slide together. And as we learned in session 1, during these initial stages, based on the client's load requirements and clean energy targets, the prospective location of the project is established, which leads the conversations into the discussion phase for the viability, potential size, and output of the project. Next, project development approvals will have to be sought. This would include land agreement conversations with the municipalities where the project is being considered, as well as preliminary discussions and approvals with the distribution or transmission operator in the region. The nature of these conversations will greatly depend on the scale of the system that is being proposed. In addition, prior to hiring an EPC, environmental assessments, initial surveys, and geotechnical work, as well as the development of protection plans, will need to be developed. Some major items that would fall in this broader category would include proximity to wetlands, wildlife sweeps, soil assessments, and pre-disturbance site assessments so that the land can be restored after the life cycle of the specific renewable system. Next up on the slide, we have insurance and bonding. The developer and the owner will need to purchase a course of construction insurance for the project to protect themselves against damages, theft, injury, and any other impact on the assets or the teams performing the EPC work. Finally, a contract or contracts will be required to hire the EPC to perform the EPC work, which is also the engineering, procurement, and construction. Generally, a CCDC 14 templated contract can be a good option to hire a contractor. Next slide, please. So what should you know about engineering? Well, some of the steps during the engineering process might have been visited during the pre-EPC stages. Often the design changes through the progression of the project, and some of the initial assessments might not be relevant or might have to be revisited to satisfy project-specific requirements. So items such as in-house versus external. This is an important decision at the engineering stage where you are likely to establish whether internal or external resources will be used during the life cycle of the project. For example, on projects where ATCO is leading the conversations, ATCO might have the in-house expertise on the various engineering and project management fronts, yet ATCO would choose to use external resources to build strategic partnerships, engage in a more collaborative environment, and tag team any aggressive deadlines. This might, however, result in extended coordination and meetings, as well as bringing external parties up to speed or apprising them of internal ATCO work procedures. So there are pros and cons to making that decision. Next up, solar PV design. From a high-level perspective, depending on whether the application is residential, commercial, or industrial, the solar engineering would typically include the electrical design, which involves the development of the medium voltage and the low voltage single line diagrams, the georeference geo layouts, and geotechnical surveys, civil foundations, piling, racking, earthworks, etc., as well as traditional knowledge from the community in the design stages. Solar design considerations would include the selection of solar modules and inverters, module tilt angles, sizing the DC-AC ratio to avoid clipping losses, row spacing, system-specific losses, including soiling losses, as well as considerations whether the system would be fixed racking or equipped with trackers. Balance of plant engineering. Well, solar and associated infrastructures are usually talked about in great detail and constitute the major portion of the solar design. Medium voltage portion is small, but usually a tricky piece. The sizing of the medium voltage gear and the tie-in to the DFO is often a time-intensive process and requires extensive coordination and collaboration. This naturally leads us to the fourth item on the slide, which is interconnection engineering. It helps us understand the distribution facility owners and the transmission facility owners in the region, their requirements, and how the solar farm will be connected to the grid. What are the regulatory requirements that need to be fulfilled? These requirements will often affect the decision-making on sizing your power plant. And finally, the environmental and wildlife impact from the execution and constructability perspective. During this phase, we understand how the conceived design from the initial stages measure up against the actual execution, as well as the design alterations and constraints that might be imposed on the design based on wetland setbacks, clearance from wildlife habitats, and other geo-constraints such as drains, ditches, and altitude changes. All these considerations make each project unique. Thanks. Next slide, please. What should you know about procurement? Well, in today's market conditions with supply chain challenges, some equipment take longer to procure. Items that get impacted by the market conditions contain a lot of raw materials that are not locally available, like steel, copper, and aluminum. In ongoing projects, we have seen almost all the materials, including transformers, solar modules, inverters, large cables, piling, and racking showing long lead times. And it has been generally noticed that having the specifications and design finalized as much as possible to start the conversation with the supplier has resulted in significant time savings. From a high-level perspective, things to consider include who takes the responsibility for ordering, whether it will be the developer, the EPC, or the utility. Defining that early on is very advantageous. More specifically speaking, delays can be avoided through early engineering and procurement practices. This would include providing enough time on your project lifecycle to perform all the engineering upfront and then ordering material, or performing specific engineering activities in relation to the long lead items so orders can be placed, or early procurement of solar panels, pilings, and cable. For example, buying solar panels ahead of time and storing them until the project moves to the next stages. And lastly, partnering with an EPC that has large purchasing power and access to many vendors and markets. With that, I'm now going to let Anton walk you through all that you should know about construction. Thanks.
Thanks, Yad. So yeah, what should you know about construction? The first thing we should look at is construction process. So the construction process sequence of events will differ depending on the renewable system that you're developing. So, and each style of system can allow for certain flexibility in the sequence of events with proper planning. So, for example, there's a roof mount solar system will be different than a ground mount solar system to a degree. They're similar, but to a degree. Vice versa, those two compared against wind generation or combined heat and power will have a different set of construction sequence of events. So it's important that you first understand, okay, what are you trying to build in that respect. So if we were to look at one example, say a ground mount solar system, normal construction sequence events, as I walk through this, could be essentially, you start off on site with your survey, you're performing your environmental activities like erosion and sediment control, you're performing your fencing construction, your earthworks, like you're putting in your roads and your pads and your culverts and your drainage, and then you're progressing to your piling. Once your piling's in, you put your PV racking on, then your solar modules on top of that PV racking. You could then complete your trenching, your AC/DC cable installation, electrical equipment, and terminations and that. But there's opportunities for overlap, that you can create efficiency, right? So you don't have to kind of do it one by one. You can find those efficiencies to shorten the project duration. So for example, your piling installation could be happening at the same time as your earthworks. And as you say, you don't have to wait for all your piling to be installed at once. You could install, your first chunk of piles, and then as you move on to the next set, you come along and you put your racking on, and then right after, a little bit of your racking is up, your PV modules can start going on. So there's plenty of opportunities to create efficiency to really shorten your project duration and your schedule duration. So one of the things we've really learned is it's good to avoid winter construction if possible. It's not always possible, and sometimes where you are, it really can be advantageous at times, but we've definitely built in the winter, and it's quite possible to be successful. So what else should you know about construction? Safety. So safety is paramount. When you're developing a project, or you're an owner in a project and you're, say, going to choose an EPC, you want to find an EPC that performs work safely, has a long track record of safety, it has a robust health and safety management system, and all that work should be completed according to occupational health and safety and governing laws. So permitting, if you do choose to hire an EPC, you can really push a lot of that work onto that EPC, and they can gather your development permits from the jurisdiction or the counties, your building permits, your electrical permits, and they can take care of a lot of that work. Quality control and commissioning. So essentially, once you're done your construction, you want to have a good EPC, or at least have it on your radar that you need a good quality control process in place. That EPC should be performing quality checks, documenting throughout the stages of construction. All the quality information is being gathered. So, and then once that is complete, you're going to move into commissioning, which will operationally test the system to make sure it's working, and that will help with the interconnection that Ziad had mentioned earlier in the engineering process. The interconnection to your DFO, so your distribution facility operator, or depending on your system, into a transmission facility operator, the TFO. So, and lastly, operations and maintenance is really what you want to think, and you want to start thinking about operations and maintenance earlier on in the project cycle. You don't want to leave that to dead last, because once you energize, I mean, if you're developing, say, a solar farm, it's going to be around for 25 years at a minimum, and so it's important that you focus on that, because there's going to be some maintenance that needs to be done. There's going to be some operations, and sometimes there's some troubleshooting that needs to happen if something occurs, and so it's important that you're thinking about that strategy and what that process looks like in regard. So, but I believe that's going to be in our next session, session 4, and so there will be definitely some more to come on that. So our next slide here is supporting community growth, and I think it's important we talk about that. I know our belief at ATCO and the experience that we have has taught us that supporting local business and groups is really key to a successful project. We can't actually do a successful project without it. And as an owner and a developer, even if you're not going to hire an EPC and you're executing that project solely, there's a lot of resources that you can draw upon depending on your community or your local. And examples of such in different projects that we've had is, local accommodations and board, local contractors, labor force, right? So you're hiring out your electrical, some civil, some mechanical support, site support such as security, water, waste, sanitation. One example I could share is there's a lot in that you could draw upon to support your project and create careers and create jobs. And one example is we had a project where we had to do a bunch of brushing. So we had to take down a bunch of trees and do some brushing, and we reached out to the local community, and we were able to employ some of the local community to help with that brushing. But then we also got to keep that firewood and use that for heating, or local community, I should say. So the last thing I want to say on supporting community growth really is all the traditional knowledge and experience and for the land and the area and the history lies with that local community. And I think it's incredibly important that we sit down and we engage and we listen, and that can help avoid risk, and it can help keep everyone informed. So we want to share a couple case studies with you. We have 2 case studies that we want to share, and Ziad will read and discuss one, and I'll discuss the first one here. So I think essentially, you know, one of the as I talk about these were both EPC based case studies, and I think there is benefits to having an EPC. It sort of really talks about you know, a one-stop shop, a one contact point. Communication paths get easier, and at times you know, you're not having to manage as much when you're dealing with a single EPC entity. So so case study 1 here is a northern isolated solar farm that we built. And it's a 2 megawatt solar farm with a 1.7 megawatt hour battery energy storage system, or a BESS for short. The project was completed largely over a course of a year, and we did have some unique challenges due to where it was constructed. So we encountered essentially the only way to bring material in and access the community with material on large vehicles was through an ice road. So we encountered logistical challenges because of that, and it required a lot of expertise, engineering, and additional upfront construction planning to avoid unnecessary material delays because of the ice road. It took extra provisions and, you know, working with local businesses as well. You know, some of the material that we did bring up the ice road needed warm storage, right? And so we worked with local businesses to find warm storage and make sure that that was stored until spring came and we could actually begin construction and we were ready. So another learning from that process was, because everything needed to come up the ice road, it was important that we received the material immediately and opened everything up, made sure that all the pieces were there, all the parts were there, made sure that nothing was damaged, because if we couldn't deal with that immediately and send it back down the ice road or get a replacement up, we'd be in real trouble. So it took a lot of foresight and it took a lot of planning. From the pictures there, you can see there's quite a bit of sand on the site when we were constructing, and so one of the methods we used to pre-plan is we brought the whole sort of construction execution team and the engineering team out to site, and we spent time on site walking through and talking and discussing how we would mitigate certain challenges around trenching, because there's, you know, so much sand and we would have sloughing, or discussing how we would, you know, how deep we had to put the piles and that sort of thing. So on the right-hand side there, you can see there's a inverter building, and so for this project being so far north, we felt it was important to modularize different aspects of the project, right? So we created a skid building that could be transported easily up the ice road. A lot of these components inside needed to be heated, right? And so we were able to keep them safe as they came through. So it's about sort of, once again, maximizing that construction schedule and making sure that you've got sort of those pre-plans in place. So lastly, just on this case study, because it was a remote community operating on diesel generation, it took you know, a lot of coordination with that DFO, with that distribution facility operator. So it's important that if you do choose an EPC, that you do go that route, that you have a really good you choose an EPC that has a really good understanding of how to work with the utilities and how to work with those DFOs. Over to you, Ziad.
Thank you, Anton. So our case study 2 is a project located in central Alberta, and it has a system nameplate rating of approximately 5 megawatts. ATCO was initially involved in the pre-EPC stages, and currently, and with the EPC phases, we've learned a lot of things. Besides the technical requirements of the project has had to fulfill certain community-based requirements as well. According to the client, the project has been or was conceived to have an important milestone in the strategic planning of the community in terms of employment, sustainability, and tourism. So if we were to make a reference of this case study back to slide 8, where we talked about engineering as part of the project, we used a combination of internal and external resources We conducted the solar design to ensure the client's generations as well as the project-specific requirements were met. The design of the medium voltage system, including the interconnection gear, was designed such that it would complement the downstream solar design as well as fulfill the upstream DFO requirements. That it was ensured that all of the DFO as well as ASO requirements are fulfilled. And it was also ensured during the course of the project that any wetlands, ditches, or places with changing altitudes, as well as significant items such as the preservation of the culturally important trees was also upheld during the entire construction sequencing or phasing of the project itself. So in the course of the project, there a lot of things, went not according to the plan. We worked through them as an owner and the EPC together, but there were like significant learnings or takeaways from the project. So, for example, to minimize coordination issues, strong communication had to be upheld with the customer, the vendors, the manufacturers, and the construction crews. Conversations ensured integration of all disciplines so that teams are not working in isolation. Any supply chain issues would alter the type of equipment that one can get. So that would result in re-engineering and looking for alternatives in the market, but such that, all the requirements of the client as well as any project-specific requirements were always prioritized, which also meant like focusing on and prioritizing the technical as well as environmental or other community needs. So all in all, the two case studies that we've talked about have kind of given us a great understanding of how these EPC projects would kind of at times follow the pre-EPC stages, but also along the course of the project or specific requirements shift and fit the needs of the community or any other funding requirements that need to be met. With that, we're done with our presentation, and I will now ask Filip to take over. Thank you.
Thanks very much, Anton and Ziad. So this concludes the formal portion of it, but we would very much appreciate and welcome any questions from the audience on aspects of this part of the life cycle. So we've got a few questions here that I'll ask our presenters to field. The first one comes from someone anonymous. What are some examples of traditional local knowledge being used in this process? And any examples, please provide.
Sure, I can take this one, Phil. So we've had projects before, and I'm thinking of one project in particular, speaking to the owner and their traditional knowledge for the site that we were building the system on. It was a solar system. They were very, very helpful around helping us with our environmental investigations. So, what types of wildlife are in the region? What types of, environmental considerations are there? Stormwater management, drainage on the site, really, what was there before, even geotechnical discussing, is it close to bodies of water? Is it old riverbed? Is it, is it farmland? That sort of thing. So, and largely as well, I found traditional knowledge very important in terms of, was there a lot of historical activity that took place on the site? Are we going to encounter historical items of significance, right? But is there areas we need to be careful of as we're excavating or doing any types of work like that we need to watch out for? So I know that's really high level, but hopefully that gives you a bit of an idea of what we've encountered and how we work with traditional knowledge.
Thank you kindly for that. Appreciate it. Another question comes forward from Nick Hawley. And it's a great question. A problem with buying solar panels early is that they are improving at a rapid pace, so will be outdated by the time you install them. Ziad, perhaps you could field this one and comment about how quickly the technology changes.
Yeah, thanks, Philip. Yeah, great question. I think the point to note here is the just-in-time delivery. So understanding what your project ISD date is and adjusting your orders accordingly as well. So if the lead times are somewhere between 3 months to 6 months, allow yourself enough time to get the material. And then if there are shortages forecasted or any global events that might impact the supply chain, just provisioning for it basically is the idea here. And like typically we've noticed, projects wouldn't always, like there would be things that would alter the schedule. So if the engineering work or specific things pertaining to long lead items have been completed well in advance, it just gives a certain amount of leverage or certainty on how these things will be managed and how you can achieve the desired supply chain or face or address the supply chain issues. Thanks.
Thanks kindly for that. Another question coming forward to us from Nick. Could you discuss the ATCO process for preparing an EPC bid? How well established was the design before you had to prepare your fixed price bid?
I could talk
Perhaps,
to
yeah,
that.
Anton,
Yeah,
thanks.
I could talk to that a little bit, and maybe I'll lean on Ziad if as well. So I think there is no necessarily one silver bullet for I guess for that answer for that question. We've had different developers come to us at different stages, different different stages of their process of development, right? And sometimes that's quite well developed, and they've even got a quite robust design in hand, sort of that feed engineering design. Sometimes it's a pre-feasibility. Sometimes there is no. They come to us and they're looking for a feasibility study, and which we're as an EPC, ATCO is more than happy to facilitate and help. Right. Sometimes it's in an owner's engineer capacity. So it's a good question. It's a little bit difficult, but I think we're able and willing to tackle any stage of that EPC preparing a bid. So.
Thanks kindly, Anton. Another question comes to us here. What are some of the other environmental and wildlife impacts you have encountered with projects in northern communities? And what's your consultation process?
So I can take that again. So largely, what have we encountered? As we're developing that project or working through the stages of that project, we're going to perform an environmental assessment. So we send a team out and they will perform wildlife sweeps. They'll check the area for different types of vegetation. Is there noxious weeds potentially on the site that need to be managed? Is there anything that's needs to be protected, right? So there's after we sort of gather that information, we take soil samples. We perform a pre-disturbance site assessment, just to essentially look at how do we return the land to the way it was at the end of the life cycle of the project. So with that data, then we can form an environmental protection plan. With that environmental protection plan, those are the steps that we're going to use to mitigate any hazards or risks we've encountered or wildlife we need to protect. And essentially we put those into place. So I believe, Ziad, you've got a pretty good example recently from a project you could share.
Yeah, absolutely. I was just going to add that in some of the work that we've done recently, we've also had to understand the impact the project will have on, for example, birds, rodents, and maybe on some wildlife, frog species as well. So in general, we've had to keep an account on not only the wildlife, but obviously the wetlands and the geo-related constraints that the project poses. So it's a holistic approach to how you will make sure that the project fits in the ecosystem that you're operating in.
Thanks kindly to you both. Another question, I think it's a great one, is you make mention about insurance and bonding. Would a community have to purchase their own?
So yeah, I can talk to that. essentially, it's recommended if you're a developer and owner, and you are going to hire an EPC or hire a lot of sub-trades underneath yourself, you would want to purchase yourself course of construction insurance, and that protects the entire work site and everyone on the work site, all material from theft and vandalism and damage and that sort of thing. Now, when you hire an EPC, that EPC is going to, and all the sub-trades below it they're going to carry insurance themselves, and that insurance is going to cover them when they're not on the work site, so they're traveling, say, to and from the work site for vehicles and the like. So you're covered risk that wise. When it comes to bonding, you as a owner developer do not have to purchase the bonding. You can put that on the EPC to purchase the bonding for performance, say, and they can work that into the price of the contract. So you essentially can focus more on the course of construction insurance, but that's a great question.
Thank you very much. We have another one from Anonymous. What other renewable technologies can ATCO develop as an EPC?
Sorry, go ahead, Zian.
No, you can go ahead. That's okay.
Oh, okay. So I don't know if my camera's on. Oh, there we go. Okay. So agnostically, we can develop and we can approach any types of, we sell energy, right? And energy development. So we're agnostic about it. We can do wind, hydro. There's, LNG, biomass, heating. I mentioned before, sort of combined heat and power systems. There's solar. We obviously focus a lot on solar, and so there's lots of different things, but we have lots of experience, and we can approach anything when it comes to energy. So.
Thank you very much. I don't see any further questions. Might give it a couple of moments, see if anything else pops in, but I want to take this moment to thank our presenters and those who have joined us. And before we go, perhaps,
Sorry,
some questions
Philip.
pop up.
Oh, sorry. Did you see that last question? It was just a follow up to the local knowledge.
Yes, you're right. Apologies. Great point about the importance of the local knowledge. Do you engage with the local Indigenous communities at the feasibility study level, or when exactly?
So yeah, I think to follow up on what I was speaking about previously, so the answer is really continuously. I think it's incredibly important that we walk step by step and we have a good relationship, and we need to be just talking, and it's this continuous process where throughout all phases of the project that we're discussing that knowledge and have that local input. So that was a long way of saying continuously. It's really all throughout the project. So.
Well, thank you very much, and a good catch there on that last question. So with all of that in mind, this wraps up the third webinar series. We've got another one coming up on November the 24th, and we would very much like as many of you to come participate. That webinar will focus on the ins and outs of how to manage ongoing operations and maintenance, take you through the steps to help organize the manufacturer's maintenance requirements, and create a successful maintenance plan. So hopefully you can register for that and join us. And if you have any further questions and inquiries, if you want to connect, my contact information is on that last slide. Feel free to reach out on any questions that may come to your mind after this webinar has concluded, and we will get back to you with a fulsome answer. So with that in mind, I want to thank you on behalf of ATCO and all of our colleagues here.